Mengendalikan motor DC dengan Arduino. Motor DC adalah jenis motor listrik yang bekerja menggunakan sumber tegangan DC. Motor DC atau motor arus arah sebagaimana namanya, menggunakan arus langsung dan tidak langsung atau direct and indirectional. Motor DC digunakan pada penggunaan khusus di mana diperlukan penyalaan toruk yang tinggi atau percepatan yang tepat untuk kisaran kecepatan maksimum atau kecepatan yang luas. Motor DC memiliki tiga komponen utama, yaitu kutub medan magnet. Secara sederhana digambarkan bahwa interaksi dua kutub medan akan menyebabkan perputaran pada motor DC. Motor DC memiliki kutub medan yang stasioner dan kumparan motor DC yang menggerakkan bearing pada ruang di antara kutub medan. Motor DC sederhana memiliki dua kutub medan, kutub utara dan kutub selatan. Garis magnetik energi membesar melintasi bukaan di antara kutub-kutub dari utara ke selatan. Next. Yang kedua adalah kumparan motor DC. Bila arus masuk menuju kumparan motor DC, maka arus ini akan menjadi elektromagnet. Kumparan motor DC yang berbentuk silinder dihubungkan ke as penggerak untuk menggerakkan beban. Untuk kasus motor DC yang kecil, kumparan motor DC berputar dalam medan magnet yang dibentuk oleh kutub-kutub sampai kutub utara dan selatan berganti lokasi. Next. Komutator motor DC. Komponen ini terutama ditemukan dalam motor DC. Kegunaannya adalah untuk membalikan arah arus listrik dalam kumparan motor DC. Komutator juga membantu aliran. Dan ini adalah video tentang motor DC.
This is a DC motor. You can tell it's a DC motor because of the cylindrical body shape and the two cables coming out of it. In this case, red and black. Now, you can actually hook these cables up either way. That's the special thing about DC motors. If I was to hook the red up to the digital out on the Arduino and the ground to the ground and set that pin high, it may spin clockwise. Or I can hook the ground cable on this to a digital out on the Arduino and the red cable to the ground on the Arduino and set that pin high, and it may spin anti-clockwise. So by reversing the polarities, we can change the direction of rotation. Now this is because inside of DC motors, there are wires, lots and lots of wires wrapped around to create electromagnets. There are also permanent magnets in here as well. When a current goes through inside of here, through all these wires, it will repel the magnets and force this axle to spin in a direction. Now, using the laws of physics, it also states if I was to reverse that, the direction of the electromagnetic field will also reverse, and that can actually repel the permanent magnets the other direction, making it spin the other way. So that's a handy little thing to use if you want to make robots. You send a current through here and make this spin. Although there are a few problems with using a DC motor by itself. Because this just uses magnets and there isn't going to be much torque behind this. Torque is how much force is behind the spinning force. For example, if this was spinning really, really fast, and if I was to put my finger on here lightly and the motor stopped, that would mean it wouldn't have much torque. It doesn't have much pushing force. Or if this was spinning really fast and I put my finger down and it cuts my finger or it doesn't want to slow down at all, that means it has high torque. Now this particular CD drive motor won't have very much torque at all, because if there's a problem with the CD, it won't want the CD to spin anymore, otherwise it could create havoc and destroy the insides of your player. So these particular motors don't have very much torque. A way of getting good torque out of DC motors is by using a gearbox. So for example, if I was to put a small cog on this, connected to a larger cog, that will give that DC motor some torque. Now they do that, they create gearboxes, and you can use tank treads and such using those gearboxes. I know Tamiya treads are really good. And that will give sufficient torque to move your robot. If you were to just, for example, use an Arduino and have each of these on both sides and put the Arduino on top of this, and say you've got a panning ultrasonic sensor, this will not provide enough torque to drive the robot. So you will need to think about using gearboxes, or you can buy continuous rotation servos. It's up to you. Okay, so we covered that reversing the polarity of these cables will change the direction of rotation. But because it's going to be hardwired to an Arduino, how do we reverse that polarity? We can't just suck in and suck out electricity as we will. It doesn't work like that. If we hook it up to an Arduino, it's always going to be an output, which means it's always going to spin in a certain direction. How do we fix this problem? Simple, using a H-bridge. This board here is a shield for my Arduino Uno. It's made by Adafruit, Lady Ada. It's a motor shield. And these black chips here, these IC chips, are called H-bridges. Now it's got 3 of them because it is a 4-channel motor driver. It can also drive stepper motors as well. So it's very powerful. Now H-bridges will have a few inputs, depending on which ones you buy, because there are lots. They may change what they do, but basically there's going to be a pin to enable the motor, a pin to decide the direction of spin, and a pin to decide the speed of the motor. Now, depending on which motors you are using, you will need to buy better H-bridges. Small motors such as this won't draw very much current, but they still draw more current than the Arduino pins can provide. So hooking this directly up to an Arduino pin is a bad idea. It can destroy your pin, which is bad. So, to fix this, you can use an external power supply, like they've done on this motor shield. There's some easy screw terminals on here, so you could just clip those leads right off. You could tin them if you wanted to, strip them a bit, and screw them into these screw terminals in here. Then, using this handy Lady Ada motor shield and its accompanying library, you can easily make DC motors move. But again, you will still need some gearboxes if you want this to move. Now, if you just want to make a simple 2-wheeled robot with ultrasonic sensors, and say you want to make an obstacle avoidance robot, for example, I wouldn't recommend this, as it uses all of the digital ports, because it's got 2 servos, it's got 4 channels, it's using a lot of ports, although it is handy how it does have the male headers for analog pins and ground and 5 volts. If you wanted to make a light-seeking robot, this would be perfect, as photoresistors can be connected to an analog pin on the Arduino. I'll cover this in a later tutorial where we actually talk about analog pins. So if you wanted to make an obstacle avoidance robot, I wouldn't recommend this. I would, however, recommend buying one of these chips and placing them on a breadboard. So you could even place them on this proto shield across this gap, and you could use it like that. So I would recommend doing that if you want to do something like this. But again, I find continuous rotation servos a lot easier to use. So if you can get them, do. If you don't want to use them for some reason, you can use a DC motor with a gearbox. So that's H-bridges. So I think that just about covers it for the theory part of the tutorial. I think it's time to get an Arduino, write some code, and get to the practical aspect. Okay, so now you can see that I've got the Arduino IDE open. I actually have the sweep example open. So that's under File, Examples, Servo, Sweep. And this is a basic code teaching you how to use the servo library so that you can control servos with the Arduino. So let's get right into it and look at what the code is actually doing. This first line here, include servo.h. This include function is used when they want to include an external library. Now, libraries are found in the documents section on the Arduino. You can go on the Arduino website and look how to properly install libraries. It should be in My Documents, Arduino, Libraries, and then you should just drag your library folder straight in there. Libraries are created to make it much easier to use things. For example, this servo library has been written by somebody else to make it much easier to use servos with the Arduino. This servo library also utilizes a timer-based function, which means that we don't have to use servos on the PWM outputs on the Arduino. We can actually use them on any pin. So this is really handy. This next line, servo little servo, I've actually just renamed this just to show you what we can do. This servo line here, you can see it's a different color. It's a function. It's referring to this library, so it knows that this is part of the library. This line here is basically just calling a servo. It's just giving it a name. Much like how in our LED tutorial we gave the pin a name to make it much easier to use, this is the same deal. We are just naming it to make it easier, and it knows what it's referring to. And you can see a little side note here, maximum of 8 servo objects can be created. So you can see there's limitations in the library. I believe this is because when you do use the timer-based functions, it disables the PWM outputs No, so I think it just disables in general. No, I think it's just the PWM outputs on pins 9 and 10, I believe. So you can't use any servos on that. This next line, int, so an integer. It's not a constant integer, it's not an unsigned integer, it's just an integer, which means this will be changed. It's not going to have very high values, it's just something that we can change up and down and use later on in the code. So pos, which is short for position, 0. So that's pretty simple, that's all that is. Now we go into the void setup. Now as you remember, in my LED tutorial we talked about how the setup only happens once, and that's on the boot up of the Arduino. So if you want to check things, set variables, check surroundings, get attach things to pins, this is all done once. Everything you only want to happen once in the Arduino program, you put in this area here between these two parentheses. So my servo.attach bracket 9. This is calling back from here. So because this is a naming scheme, I can rename this little servo.attach 9. So so it now knows in the program that we've attached a servo to pin 9 on the Arduino. Okay, so that's easy enough. Let's have a look at the void loop. For position equals 0, if the position is smaller than 180, set the position relative to +1. So this is rather simple. So it's just going to go all the way up to 180. If it's below 180, it's just going to keep adding 1 on. Now this is the variable. As you can see, the variable starts at 0. So while position is smaller than 180, the variable position will keep gaining 1 continuously until it gets up to 180. My servo.write position. So again, we've renamed that, so we can rename that to little servo.write position. This write function is now telling the servo where to go, and we want it to go to the position variable. Now we know that the position variable is just going to have an integer value, so that's easy enough. It's just going to get that value and go straight to that angle, because this will be an angular position, 180 degrees being half a turn. Sorry, being a full turn for a 180 degree servo. Delay 15. Now you can see it says wait 15 milliseconds to reach this, for the servo to reach the position. That's because you've just written a position to the servo, and if you were to write another position to that servo instantaneously, it won't actually go to the first one. You have to tell it to go to the first one and then wait for it to get there. Then you can tell it what to do afterwards. For position equals 80, if the position is larger than 1, set position relative to -1. So once it's gone through this code here, and it's reached 180 degrees, because as we said, if it's smaller than 180, set it to relative to +1. So once the variable is equal to 180, and if it's still larger than 1, we will subtract 1 from it. So it's gone up to 180 degrees in this section, and now it's going back down to 0 in this section. And again, we'll change this because I've changed the name at the start. Little servo.write position, again, just writing the position of the variable to the servo. And again, we want a delay to make sure that it gets to that position. So what you can do now is upload this to your Arduino board, and then we can hook the servo up to the board and see what happens. Okay, so once you've got the code uploaded to the Arduino, it's time to get the circuit going. So just grab your servo. So I'm just going to use my little 5-gram servo. And I've just put some male breadboard jumpers on the ends with the appropriate colors. And I'm now going to put them into the board. So the yellow, the signal wire, goes into pin 9, like so. I'm going to put the ground in this row, and the 5-volt lead, or the voltage in lead, sorry, in that row. Then what you have to do is get another male breadboard jumper, connect it to the ground, and then connect it to the ground on the Arduino board, like so. Then you'll want to get a power supply. I've got this handy little 4.8 volt, 500 milliamp rechargeable battery pack. So it's just 4 rechargeable AA batteries. with a connector. I've charged it up, and now I'm going to plug the leads into the breadboard. So put the voltage in there, and the ground there, and you should hear, I don't know if you could hear that. I'll see if I can hold everything up at once. When I plug the ground into the board, you'll see it twitch. Do it again. There you go, see that? Okay, so that means that we've got power and it's all correctly, and you can see there's no smoke coming out, which is good. So now we know that there's power going to the servo coming from the battery pack. So what we can do now is give the Arduino some power and see what happens. And make sure that you've got your pins on the right leads. I actually had that in pin 8, so put that in pin 9. You can see it's moving. So that's very simple. Now it's good because they're running off separate power supplies. So this servo's got its own power supply, and the Arduino's got its own power supply. So you're not going to burn out any pins or anything like that. The servo's not drawing hardly any current because it's just using a PWM pin. All the main power draw is coming from the battery pack. As you can see, that works very well. So that's how we do that. So now what I might do is get a DC motor out, and we can see what we can do with that. So what I've done now is hooked the motor shield up to the Arduino and uploaded the motor test example sketch. And I've wired everything up to a robot base that I have. It's powered by 2 DC motors, and there's wheels on each side. I've just hooked up one DC motor. And you can see it's very effective at moving a robot. Now, of course, if you were to spend more time on this, you could get both of the wheels working. You can use the analog inputs on the motor shield's board, connected to the Arduino, and hook up some photoresistors to make a light-seeking robot. But you can see that it's very effective at moving a robot around. Now, if I just grab it on its way around, and I pull the power out, what we can do is have a look at the underside of the robot, and you can see, it's got some DC motors, it's got a gearbox in there, so that's what the gearbox is. That's why you need the gearbox. The gearbox provides the torque to make the robot move. Now, if you don't have a gearbox, no torque, robot's not going to move. In this case, it has 2 DC motors, both with gearboxes, and we've basically just made a robot. Now, in the next tutorials, I will be going more in depth with more things, like analog inputs. And once we've covered enough, I think after the analog input tutorial, since we've covered LEDs, we've covered DC motor control, I think we'll do a tutorial on making our first light-seeking robot, I reckon. So that's all for now. I'll get back to you with the next video.